All right. So we are back, everybody. So here, last video got cut off, but whatever, that's cool. So we're basically right here. Oh, oh goodness, what's that? Hmm. All right, cool. We'll get to that soon. That's cool, man. We built this city on rock and roll. So anyway, we're right here. We're in Linux kernel, fooling around, looking around. I think the last thing I was looking at was some sort of console for it was a Braille console, something like that. I think this is it right here. Console for accessibility. That's correct. So we're just cruising around, looking around. We were seeing all these different kinds of buffers implementations. That's right. So we had a specific buffer that was implemented specifically just to handle the console that's associated with a particular system to support Braille for accessibility purposes for Linux, which I didn't know, didn't know anything about. That's pretty cool. So anyway, we were just perusing around and looking around the code. Um, so you got a couple of things here, right? So we get the size, right? The size of this synth buffer. Exactly what this is for, who knows? Guess what this is for? I don't know. That's a good question. It's funny to see comments like this inside of Linux kernel. Let me turn that music down. That's one notch. But anyway, it's kind of funny to see this in the Linux. Oh, good. It's just all right. So anyway, so that's that. So we got a couple of variables that are defined here. So quite obviously, this is a pointer that's going to be pointing to this particular array. All right. That's pretty much all we got. And here we go into the end of the array. That's pretty much all that is, right? So if you think about it. So and then here we got a function. Um, what's kind of interesting is that these are static. So static is being used here. All right. And I guess this is not a pure function. I wonder why wouldn't you use a pure function? Right? Yeah. Learning the difference between a function and what they call a pure function in C. The reason why this wouldn't be considered a pure function is because it's operating on variables that are external, right? So, whereas if you think about learning and understanding the stack in C and how the stack in C actually works, um, it is interesting, right? It's interesting that if you're going to operate and have a pure sort of function, this function has its own stack, right? And essentially, just like it sounds, it's a stack, and it actually goes ahead and it just functions in a way where it operates, line by line sequentially. Now you can do funny things like, have a go-to, and that's why I guess go-to is sort of frowned against. You don't want to be go-toing and doing a go-to here and a go-to there and a go-to there and whatnot, because now that's going to slow down the way the program operates, right? If you're trying to optimize things. This is kernel code, so I assume you want to be as efficient as possible, right? Um, so anyway, so we got a couple of other constants that are defined, but it looks like, we'd have to sort of scurry around to find out where these constants are defined. Whatever. Let's see. Click on it. Let's see where it takes us. Click on it again. Let's see where it takes us. It takes us to, okay, a vt.h file, and it's just 63. So it's for some sort of serial lines start at 64. So I assume minimum is, okay, so serial lines start at 64. So we're going from 1 to 63. These constraints are also useful at user level apps, whatever that means. Okay, so VT. So exactly what VT stands for I'm unsure. I don't know. I don't have a clue. So this somewhere we're inside of a. Oh, okay, I don't know what Let's see. Where we are at, we are in H. So H apparently is, so we're in some sort of, okay, so we're in includes. Includes obviously is huge. U API, some sort of U API, maybe, I don't know, utility API, who knows? I don't know, Linux and then UT. All right, so something else to peruse and check out and understand at some later point in time. We don't want to go on a rabbit hole. Here we're just fooling around in this particular thing here, and then we're just looking around here. So here we have some other variable that's not defined inside of our buffer. All right, so we're just sort of looking at where these variables are coming from, and this is defined in a in a file called main. Okay, along with all manner of all sorts of other things. So we have a short here, short static. Anyway, so let's go back here. So we got this guy, which is 63. Ah, okay. So it's a bunch of pointers. So speak up console is an array of pointers, right? Right. So, okay. Well, let's go back here. Oh, let's take a look here. Oh, that's pretty cool. Interesting. So let's go back here. I just wanted to try something out. This is something interesting here. Let's go ahead and ask our little buddy here. Mm. All right. So you're going to use the AI. 240 and array of pointers. Let's see what he says. Survey says yes. Line 240 declares just an array of pointers to blah blah blah. See, is the array size versus the console typically? Oh, okay. Each element in such as a pointer to a blah 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 blah. The array itself is a global, no static, so it's accessible across translation units. What the hell is it? Oh, okay, cool, cool. So this is compiler speak, I believe. Let's just make sure. What is a translation unit? Translation unit is a single source file after the okay, see, has run, meaning all includes and such has been parsed in and all such and such macros, check and such and such. So I told you that's compiler talk. So accessible across translation, it just means other .c files can see and use it. Blue. Okay. All right, so that's cool. So other C files can use it. It's globally defined. That's beautiful. So, all right. So, anyways, we got a bunch of pointers, and it's just going through here. So nothing too amazing here. All right, just a simple for loop here. We're doing some sort of export. This looks like some sort of macro or something like that. So exactly what the hell that's doing, I don't know. Let's find out. Let's see. So, it looks like I am correct. It's some sort of a macro. We're passing that in, and it's doing an export symbol. This is another macro. And the export symbol is doing something else with another export symbol. This is up here, which is doing an extern of this particular type. Oh, okay. All right. So that's something. We got a lot of macro fun going on there. What else we got here? We got another function here. Stop the such and such, and so nothing interesting here either, right? So we just got a for loop executing a couple of conditional statements there. Blah 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 blah. And nothing interesting here. We just got some, integer there, doing some integer fun, integer math there. Probably going through, freeing up the buffer. All right, and no big deal. Just determining whether or not we got to some point of the buffer there that they're equal. Doing some more exporting. So as we see, this is just like this is like some sort of GPL stuff. We had read earlier, I think we had read about this GPL versus non-GPL licensing and all that kind of stuff. Kind of interesting. Here we got what else we got? We got a synth buffer, just getting in a char here. Nothing special here. I guess we just want to make sure we understand or know where the hell this variables come from. Let's see this video. So this is coming from, let's go to the videotape. This is coming from synth.c. So synth.c. It's got something else going in there, and that's some sort of pointer as well to this particular strut. That's a big strut. Strut has all kinds of version information, names and all that kind of stuff in there. So I guess it's string, version, name, and a bunch of other wonderful pieces of information. And of course, other struts as well. All right, let's see. Hold up, guys. Let's see what you got. Oh, let's see, you got a little. Oh, okay. Yeah. So, yeah. Okay, so what else? So we got, anyway, so we got the struts and we got some definitions. We got a lot of different kind of tons and tons of data structures, of course. We're looking at kernel code, man. So anyway, so we're using pointers all over the place. So every variable, all the variables, I guess, so far that we've seen is basically just pointers. I mean, an array is not a pointer, but close, right? So anyway, so we got that. Nothing else going on here. We're freeing the buffer. Obviously, we're calling free buffer up there. Yeah, nothing special. Buffering around, pausing here. What else we got? We got here. We're going through here. We're doing some, nothing interesting here. A couple of conditional statements. Such and such. We got our exporter again. PNGPL. Nothing interesting. Skipping around. So we got something going on here, less than some sort of hex number. See now, when you wonder to yourself, right? So we are seeing a hex number reference in here. We're also seeing this number, this number 100 and number 1 in here in this file. All right. So you wonder, why would you do that? Why would you just use a literal number here? We don't know what the hell the number means, but you're just going to leave it there. So we're just kind of left guessing. Whereas, why wouldn't you create a variable, pound define, whatever the hell you want to do? In this particular case, you pound define it, you give it a name, you put a comment there, right? So that's kind of like to me, like, why would you deviate? Everything was flowing so wonderfully and nice. So you got these three, well, four, five, right? You got these little areas where you're putting the actual physical numbers in there, as opposed to using something like a pound define and then giving us more detail about the variable. I don't know. So to me, that's kind of like a little off, right? I don't think that's nitpicky, because everything else just sort of flows and it's kind of neat. So why would you just all of a sudden just think that that's okay? I don't know. That's not okay to me. So for me, I would actually change this, right? By actually, I wouldn't even do it myself. That's how bad this is. Hold up, I'm gonna ask my boy right now to do it. Yeah. Hey, come on, man. Check this out. Okay, check this out. Update this file. Replace all numbers. Now let's say, hold on. Create. Right? Create. What the hell, man? Create. You gotta get your thoughts together for you, right? Create. For each number in this file. Let's see what it does. Let's go. Okay, so we just want to make things a little bit more neat. Let's see what we're gonna do. Right. Okay, let's see. Okay, how about this? That's cool. About the zeros. Oh, it said what, not what. All right, let's see. We had to. Oh, good catch. Oh, thank you. Let's see. Let's see if it's going to be smart enough to actually replace him. Let's see. Okay, so let's say we're going to say yes. Okay, let's see the next step. Now, oh, okay, you're going to replace each one. Okay, cool. Let's go. Beautiful. Let's go. Okay. All right. So we replaced them all. So now, don't you think that's okay? Bye. Let's do that right there. Let's go. Go ahead. All right. So there we go. So numeric such and such. Cool. So now there you go. Now is that not a little bit cleaner? Right? I mean, we don't know. We still don't really know. We're just assuming, what the hell. I guess it's probably assumed. Maybe it knows. I don't know. But isn't that cleaner? I think that's a little bit cleaner. Now everything is all variables. We got some things. You know, good. Okay. Add the comments. Add the comments for each new. All right, there you go. So let's see if that'll work out here. I mean, it probably won't work out with the thingamabob. Well, that's cool. So there you go. So there you go. So that's cool. And that's how you kind of want this file to kind of go and flow. So I just think that's a nice little update, clean code and whatnot, ski, whatever. So anyway, so that's cool. So we keep on perusing on, and yet we see yet again, we got these numbers and whatnot in here where, to me, I'm like, well, why not just pound to find all these damn things, right? Like, what the hell does that mean? I don't know what the hell that means. You know? I mean, I'm just saying, we want clean stuff. We want to have comprehensive code and whatnot, ski. But anyway, whatever. All right, so we got things like this buffer to, yeah, 256. Or at least give us a comment and tell us what the number means. If you're gonna put the number there, that's cool. I mean, give us some comments. This is kernel code we're flowing in here. I'm a embedded systems deep diver, developer, engineer, cutting edge kind of person. Not really, but you'd want to know these things. You know what I'm saying? I think you'd want to know these things. These things are very important. Very important. Anyway, so yeah, so we're just dipping through these files in here. Um, just checking stuff out, looking for interesting things. So that's just nitpicky code review crap. Not really a big deal. So what else do we got? So we got here nothing interesting here. We got a buffer, blah blah blah. You pointer to the buffer here. What are we doing here? We ain't doing no. Oh, what's this? The hell is that? So we got this might be some sort of constant or something. Let's see where this comes from. I don't know. I guess the name is interesting. So let's find out. Okay, so we got a pound defines. You see what I'm saying? So you got all these pound defines here. All these are error codes and all that crap. Which okay, I get it. Cool. So that you'd expect cleanliness, clean stuff. That's nice. That's beautiful stuff. So hats off. Why the hell is that negative? I don't know. That's a wild one. That's interesting and strange to me that you got a negative error code, right? Okay, well, that means something somewhere. I don't know. Anyway, so if we're going on here, we got a count going on. We're counting things. Um, you know, okay, if it's greater than zero, okay, this doesn't necessarily have to be a constant, right? So we just want to make sure that that doesn't go below zero. So yeah, all right, yeah, just fine. The 256, to me, that would deserve a comment because you just want to know 256 why, you know what I mean? So, but whatever, that's cool. And 256 is a very recognizable number in the world of software development and creation and all that stuff, dealing with things and words and lengths and all that kind of stuff. So yeah, but still, a comment would be nice right there. What do we got here? So we're talking about min, max between these two. Right here, getting the size of the buffer. We got the bytes. Exit condition is that. So we're just constantly, decrementing the count by the size, number of bytes associated with whichever one of these things is smaller. Cool. And we're constantly checking that. So count is constantly, okay, being, decremented. The size of the buffer. Oh yeah, I don't know if that, yeah, it's not change. I don't know if this is changing or not. Oh, copy from user. Okay. Where is that? Where is that at? So copy from user is in a header, view access. So what do we got here? So there's an inline, static inline. Okay. All right. Always inline. So we got some inline action here. So you're gonna check size. I would think that this is some sort of inline. Yeah, exactly. Makes sense. I mean, one inline deserves another. Huh? So you can keep on going down the rabbit hole. So you got a whole bunch of inline operators going on here. This is some sort of built-in thingamabobber. And I think, is this assembly-based stuff or something like that? Let me see. I'm curious. I don't know how these work. So we're doing addresses, right? All right. So I'm not, this is interesting, because these underscore built-ins, I think some of those actually access some sort of assembly type code or something like that. Not sure though. Not sure. So that's something I'm going to look up. Let's see. Underscore built-ins. I'm sure you guys out there know that, but hey, this is me just going through all these things, learning and trying to develop a comprehensive understanding of these things. Now, of course, going through these files and just picking around like this is not meant to develop a comprehensive understanding. It's just meant to get a sort of a feel for kernel code, looking around in it, and then sort of to paint the picture, or sort of just to give the feel. Because eventually, what's going to happen is I'm going to just, I'm going to go through the various kernel books, right? I'm going to throw that up on the screen, and we'll have the diagrams and all that crap up there, along with the, some of these sites. So I found this other site right here, you know, um, where I guess I don't know if these coincide, right? I'm not certain, right? Because you see things like an update 18 hours ago, and this is like 35 hours ago. So I don't know if this is the same, same area, whatever it is. I don't know what this is all about, and so something to look around at, something to learn about. Yeah. But yeah, so yeah, so anyway, so continuously going down the pipeline here. Um, So yeah, so we're just fooling around. We're just looking at time to probably peruse another piece of code here. This is accessibility, Braille, speak up. So that's cool. It's a very interesting part of the code just to know that that's there and just to fool around with. So let's see what this is. An ACP Ah, whatever the hell that is. Okay. Let's go in here and see what we got. So there's some sort of driver. So we're in the device driver land. So all right, device driver land. So we got some kind of strut here as being defined. It's not being defined as a, well, let's see. Okay, all right. So where is this defined at? Okay, here we go. Hmm. So that's defined inside of this header right here. Has a bunch of underscore, you know, types and whatnot. And here's a bunch of type defs, and this is in DRM. Okay. So yeah, this is how you get portability here and consistency by using these particular types right here. Um, yeah, pretty cool. Okay. So yeah, so DRM. All right. So that's interesting how they define these things that way. And we can keep on going and going. All right, as far as where types are and how they're defined. And all of this, I believe, is defined in this particular way to sort of maintain some sort of portability or something like that, right? Because you want to know that when you're going from one system to the next or whatever it is, depending upon, your architecture, the architecture that you're using, hey, this int right here will be 8, right? 8 bytes. You know what I mean? So you want to have that, consistent dependability. And that's what I'm believing. That's what I think. Um, so you wonder though, is this like the types for the whole entire kernel? Or are there different types? You know what I mean? And why do we have so many different types if there are different types? I don't know. So that's yeah, yeah. I don't know. So anyway, so let's keep on going down the rabbit hole. This is interesting here. So you're just pretty much making type defs for these unsigned characters instead of, okay. Oh yeah, well, so okay. Yeah, I mean I've used these types before, so it's cool. Interesting though, interesting to see this location types dot h. Okay. All right. Oh, it's up in there. Okay. So this is like if C++, if this is defined, then include this. Do this. Do one of the extern joints right here. All right. So it's going to allow this to be, this to actually be put into place. And I guess I'm assuming that there's some sort of a corresponding N1. Let's check this out. Let's check that out. Let's see. Let's see. Yeah. No. Okay. Wait. Let's see. If defined, then such and such. Right? Okay. And there we go. Okay. It's the closing. See, this is the closing right here. So that makes sense, right? So if this is defined, and we're going to allow some sort of extern thing going on here to wrap around this whole thing and do an extern on it. Extern. Let's see, hold up. Let me see. Here we go, extern. Let me see, hold up. Oh, wait a minute, I'm getting there. Okay, let's see. There's a little chat going on there. Some people are contacting me about stuff, right? So anyway, so let's go. Let's go. Let's keep on going down the rabbit holes. We got another strut here. So you're gonna have makes sense to have all of these different struts and whatnot. Ski, dealing with drivers, right? Because you're maintaining certain structuralness as you're communicating through these drivers and utilizing them. And here we have another negative. Negative. Is this an error code? I guess this is going. I'm betting it's going back to our error code list. Is it? Let's see. Error codes used in the secure CRT functions. All right, whatever the hell is CRT functions? Cathio Ray 2? I don't know. All right, so That's cool. That's cool. That's cool. So, all right. So we're just going around. We're perusing around, getting a nice feel for it. We're not seeing anything of amazing interest here. You know, I don't see anything that's like mind blowing here. Let's see what you got some sort of thing going on there. It's checking the status. Okay, we're doing a reference here. Now, I'm curious. Let's see about this particular variable. Okay, so okay. So AC. Okay. I'm wondering why it's showing me the AC inside of a structure. Hmm. Okay. Oh, okay. Well, maybe it was passed in. Maybe this is being used in AC is passed in, and this particular type. And I get it. I get it. Basically, well, I kind of don't get it. No, I don't get it. Okay. So because, hmm, hmm, yeah, I don't understand because this is unto itself, and these are two totally different types. Well, I guess our our what you call it is confused then. Yeah, our IDE is confused as to what the hell this is references and what this is all about. All right, because he's talking about power supply AC, and this over here is talking something about something totally different. Incompatible. What the hell's going on there? I don't know. It's like crazy. Okay, so yeah. Wait, hold up. Wait. It has a power, so this AC does have a power supply in it. All right, so that's interesting. I don't know. I don't know. That's yeah. Anyway, so I was just kind of that is doesn't make sense to me. Yeah, it doesn't make sense. So I think our IDE just doesn't know what the hell is going on. All right, because this variable is obviously being passed in. Yeah, it does have something to do with some sort of adapter, AC adapter power management type stuff going on here. So well, whatever, happens. You know. Uh, so yeah, we're not doing anything. It says error reading AC adapter state. Okay, well, that's kind of interesting. So failure to read it, and then we return whatever this error code is. Otherwise, we return 0 as happiness. As we all know, happiness is 0, right? Nothing, everything is nothing abnormal found. 0, nothing abnormal found here. So anything here, nothing too interesting. So we're calling that here, which we call that. Okay, whatever. Nothing too spectacularly interesting here. So all it does is replace that with that. So you would wonder here, I'm not sure why, right? Why would you make this kind of a, what I'm saying? What's the logic there? You got this pound of fine here, right? Which is just going to replace it with this. So why wouldn't you just take this and use that there? Right? Meaning that, hey, I got this pound defined function here. It's going to be, during compile time, I believe, right? This is literally going to be replaced there. So you're literally going to have that put right here. All right. So I wonder if it has something to do with the way this. See if we can find that. This is defined, or where is defined at? Oh, okay. Probably, huh? Probably it has something to do with whether or not how it's going to play out based on this right here. Hmm. Okay. All right. So maybe that's something. Now that's kind of interesting. So you want to develop an understanding of why that is the case. So let me write that down. So we're gonna little things to learn from the kernel code, man. Okay. So all right. So several things to learn from the kernel code. So that's interesting to actually understand that definition of these functions as it's based on licensing associated with particular functions. Right, right, right. So that's cool. Okay, so yeah, definitely learned something new there. So that's a cool little strategy right there, cool little tactic to use in the C programming. And here we have an enum. Wow, I haven't seen an enum yet. I was wondering where these things would pop up. So here we have an enum, boom, an array of enums that literally only has one enum inside of it. Okay. Well, okay. Well, okay. Well, maybe there's going to be more enums used at some other point, right? Ah. Woo, look at all these enums. Hell of a lot of enums. Nummy, nummy. E, nummy, nummy. So yeah, it starts from 0 and it just progressively goes on. All right, so it increases from 0 all the way to whatever the hell, all right, sequentially, I believe. That is how that works. So yeah, it looks like they're pretty consistent in terms of the way they define their enums in this thingamajabba. Except for this here. So you're not naming the whole entire thing. Okay. So you got differences in the enum conventions or how it's actually being defined here. But that's interesting to see, right? To actually see, like, for whatever reason, this is a pack of power supply property enums, and this is just, what up? You know what I mean? This is just like willy nilly. No naming. I don't know. I would think that you probably want to have, I don't know, man, some sort of consistency in there. So this is power supply. Oh, okay, so we're in the power supply.h. It says all voltages, currents, charges, energies, time, and temperature in UR blah 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 and degrees in Celsius. Its driver's job is to convert its raw values into units, which is for systems where the charge determines the max battery capacity. Okay, okay, that's cool. Well, that's a rather large file with a lot of enums and probably possibly some other functions and whatnot skiing here. Oh, lots of structs, functions, and whatnot to plot. So it probably models various power supplies and all that kind of stuff. Info, metadata, and information associated with the power supplies. And even, energy waves. This is pretty cool. Look at that. You got energy waves up in there. Yeah, this is cool, man. So we're really perusing through uh yeah, we're really perusing through these different yeah. Oh, how much where we at on time? I don't even know. Oh, goodness. Sorry, guys. We're probably gonna have to. Yeah. So anyway, so we got lots of information here. This is pretty cool. Good. This is probably a good read here to, if you're doing anything associated with power supplies and all that kind of stuff, and making your own drivers and whatnot. Ski. So that's pretty interesting, I'd say. That's interesting. Okay, so let's go back here to where we're at. Perusing around, looking at some other driver stuff. All right, well, so we've seen some driver madness, some interesting driver stuff. Let's see, let's go. Let's get out of driver world. And so we're gonna get into FS, maybe file system world. Oh yeah, file system world. We are in the file system. And let's go down to something that is familiar. EX. Yeah, let's go to E. Let's go to ES4 here. Let's see what they got in here. Starts from the very top here. Let's see what we got. It says convert from file system to in-memory representation. Yeah, this looks interesting now. We got a lot of candy going on here, guys. So here's our function signature right here, right? So it's some sort of static juiciness going on here. All right, okay, cool. So let's see what we got. So void pointer. Ooh, so you're gonna have to convert that void pointer into something that is usable, right? Something that's comprehensive that we can actually see and understand. Something with a type. Otherwise, well, what's the point? All right, so here we go. So we're converting this into some sort of a char pointer and whatever the hell is at the end. So we're at the end, whatever the size is, all right? So that's cool. So we're at the end of this thing. There's some number, there's some counting. It'd be nice to have some comments right here to discuss and tell us what's going on. But that's, okay, well, I'm just saying. If the value of whatever it is we're trying to fool around with, right, bye-bye. If it's nothing, if it's nada, bye-bye. Right, bye-bye. So if you're 0, bye-bye. Okay, all right? So what do we got here? We got, all right, size of, is if this, clearly if this size, so we got a problem if the size of whatever we're passing in is smaller than this particular size. And I guess it's some sort of strut. And so this strut, whatever the heck this is, and this is some sort of type here. And we could go down the rabbit hole of this thing. You see, look at that. See how they defined that hex number? They actually defined it in here, which I would expect. Oh, so we got some bitwise yumminess going on here. All right, it says kernel doesn't use this legacy form, but user space does. Okay, so well, some sort of legacy stuff going on here with bitwise bitness. Okay, we ain't gonna go too deep into that. Okay, let's just continue and go back up here. All right. So what we got going on here? So we got some sort of if statement. And if this particular statement happens and occurs the way it doesn't like, and then we're out of here with some sort of error. And this, let me see, error pointer. Okay, what's that? I don't know what that is. That, oh, it's trying to search. Okay. Hmm. To preview search icon such and such and such. Okay. Well, right now, guys, is searching. I don't know what the heck is it. Whoa, I guess anyway, so it's trying to search to figure out where error pointer is actually defined at, which is okay. I'm not going to worry about that. I mean, I would say, wouldn't you just start up inside of one of these right here? Right, but I mean, it's literally going through thousands and thousands of files rather than these four. But then again, these four could have includes that include that include that include the include. I get that, so that's fine. But anyway, I think right now is a good place to stop. We're fooling around. We looked at some drivers. We looked at console for the accessibility. And here we're just stopping at the file system. And, from there, we'll, keep on perusing. With my goal for these videos is to, right, to not review every single file yet, but to actually just get a feel for the different types of things going on inside the Linux kernel. And then what I'm going to do is once I do that, by looking around various directories and whatnot, then I'm going to lay out, make a little image that lays out the directories and whatnot, all right? And essentially what the directories map to, like the modules and parts of the system. And then from there, after that kind of video, what I'm going to do eventually, I'm going to have a video where I'm literally going to go through every single line of every single file inside of the Linux kernel, line by line, to actually, just go by each one and just be like, okay, I touched it. You know what I mean? Right? So that's pretty much the idea. And the idea is to, find interesting things that are going on inside the kernel that we can learn from and understand and develop, um, some more insight about the C language, using C and all that kind of stuff, as well as to comment on the code. Pick out things that are crazy and like done to me that are done cool, and other things that are just like, what the hell, why? Yeah, see here, hey, we're doing this. We're using a go-to. Now that's kind of interesting. Inside the kernel, we're using go-to fail. So I guess that's some label. It's probably labeled somewhere. Okay, here we go. Yeah, so we're going to that label, and we're actually going now. See now, fail. I guess fail is always cool, and it's okay if you're jumping down to some other place inside the function, right? I've seen that, and I've seen that used, and usually when you see it, you use it in such a way where you're staying inside of that function, um, which to me, I guess, is okay, right? I mean, but as long as you're sort of maintaining that stack, right? Because if you do things to, deviate from maintaining the stack and whatnot, then you kind of add complexity to the compile tree and stuff. I think something like that. So anyway, so let's continue this at some other point in time. I will be back and we will have fun, more fun. Peace. Peace.